and advanced critical reasoning tests. Like fractions and proportions, ratios are used to compare two or more quantities. A colon separates the two numbers being compared. For example, 2:3. In words, we say the ratio is 2 to 3. Ratios do not tell anything about the total amounts. In this way, ratios are often used for recipes and mixtures where total amounts aren't known or are adaptable. Let's look at an example. Let's say that for every 5 students in a class, there are 2 computers. The ratio of computers to students can be presented as a ratio of 2 to 5. Note that the order of words in the sentence is very important. The ratio of computers to students is 2 to 5, whereas the ratio of students to computers is 5 to 2. Changing ratios into fractions. Any ratio can be changed into a fraction. For example, if in my cupboard the ratio of shirts to skirts is 2 to 3, it could be said that there are 2/3 as many shirts as there are skirts, or that there are 1.5 times as many skirts as there are shirts. Let's now look at an example from one of our practice packs. The table shows fashion industry sales for both local designers and chain stores. The question asks, what is the approximate ratio of local designers to chain stores? The total number of local designers is 1,214, and the total number of chain stores is 5,927. In order to answer this question, we need to make a comparison of these two figures. If we divide 5,927 by 1,241, we get 4.88, which can be rounded up to 5. So the approximate ratio of local designers to chain stores is 1 to 5. That is, for every local designer, there are approximately 5 chain stores. Transferring decimals into ratios. Let's say the ratio of cars to bicycles is 0.13. This means that there are fewer cars than there are bicycles. To transfer this decimal into a ratio format, we must divide 1 by 0.13, which gives us 7.69, or approximately 7.7. We can now write the ratio as 1 to 7.7. Thus, there are 7.7 bicycles for each car. Understanding ratios in more depth. If there are shirts and skirts in my cupboard in a ratio of 2 to 3, then there are 2 shirts to every 3 skirts, giving 5 items of clothing in total. The amount of shirts in my cupboard is 2/5 of the total amount of items in my wardrobe, and the amount of skirts in my cupboard is 3/5 of the total amount of items in my wardrobe. Caution: the ratio of shirts to skirts is 2 to 3. However, the ratio of shirts to total items of clothing is 2 to 5, where total items of clothing is 2 plus 3, which is 5. As a fraction, 2/5 of the clothing items are shirts. Note that it is very important to understand what is being compared to what. This is a common cause of mistakes. Basic calculations using ratios. Let's say I have red and blue marbles in my bag in a ratio of 1 to 5. There are 36 marbles in my bag, and I would like to know how many of the marbles are red. The ratio above tells us that there are 6 marbles in each set, that is, 1 red and 5 blue. 1/6 of the marbles are red, and 5/6 of the marbles are blue. In order to work out how many of the marbles are red, we calculate 1/6 of 36 is 6. Likewise, to work out how many marbles are blue, 5/6 of 36, which is 30. Let's now look at an example from our testing system. The chart shows some statistics about the South African population. We see from the chart that the total rate of HIV in 2010 is 240 per thousand, or 24%. The question tells us that the rate of HIV in urban areas is greater than 240. Looking at the urban to rural ratio in the table, we can immediately infer that the rate of HIV in rural areas must be less than 240 in order to make up an average of 240. This leaves us two options, A and D. We now have to input this information into an equation of weighted averages. The proportion of the urban population is a fifth, and the proportion of the rural population is 4/5. Inputting this into a weighted average calculation gives us 1 times 320 plus 4 times the rural rate of HIV divided by 5, which is 240. This gives us that the rate of HIV per thousand is 220. What happens when a side of the ratio experiences an increase or decrease? Let's take the previous example of the marbles in my bag. If I now switch some of the red marbles to blue marbles so that the total number of marbles in the bag is still 36, but the ratio of red to blue marbles is now 4:5. In order to work out how many marbles in the bag are now red, we need to first work out how many marbles are in each set. The ratio above tells us that there are 9 marbles in each set, that is 4 plus 5. So 4/9 of the marbles are now red and 5/9 are blue. We calculate 4/9 of 36 is 16. That is, there are 16 red marbles. Note that since the total amount of marbles in the set has changed, the set is now composed of 9 marbles rather than 6, as was the case previously. A common mistake here would be to calculate 4/6 of 36, not incorporating the change in the set. Reduction. Let's look at another example. Let's say you have 15 items in your wardrobe, 6 are shirts and 9 are skirts. The ratio of shirts to skirts is therefore 6:9. Like fractions, ratios can and should always be reduced or cancelled down until they are in their simplest term. The above ratio becomes 2:3. Tip. In order to help you cancel down a ratio, it is useful to convert the ratio into a fraction. For example, 6:9 becomes 6/9, which is 2/3, and you can then convert that back into a ratio which is 2:3. What happens when one side of the ratio is increased or decreased? Example. There are 10 employees in a company. The ratio of women to men is 3:2. If the company increases its male workforce by 50%, what is the new ratio of women to men? If we increase the men's side of the ratio by 1.5, we get 3. That is, 2 times 1.5. The women's side of the ratio stays the same at 3. The new ratio of women to men is 3:3, or cancel down 1:1. Let's look at an example from our testing system. The table shows some statistics about the populations of Thailand and Nepal. If the rates of changes of the ratio stays the same at 3,